Hello everyone. In this video, we'll discuss about the scheduling in operating systems. Um, Definition of CPU scheduling. CPU scheduling is a critical function within an operating system that determines whenever the result process in the ready queue should be allocated the CPU for execution. Significance of CPU scheduling: optimize the CPU utilization. Effective scheduling ensure the CPU remains active when they are task ready to run, thereby maximizing CPU usage and reducing the idle time. Efficient process management with multiple processes in the ready queue. CPU scheduling establishes the order of execution, enabling the system to allocate resources effectively and manage process effectively. Enhance the system performance. The choice of scheduling algorithm directly influences overall system performance, including factors like throughput, the rate of process completion, latency, and the fairness. Support for multitasking in modern operating systems. CPU scheduling is essential for multitasking, allowing various processes to share CPU time fairly and preventing any a single process from dominating system resources. So this is the CPU scheduling. So the CPU scheduling is therefore further divided into two types, which is the primitive and non-primitive. And the primitive is divided into two subdivisions, which is like which is like priority scheduling, longest remaining job first, and the round robin. And the longest remaining job first is then subdivided into it's like a shortest remaining job first. Whereas in the non-primitive scheduling, shortest job first and longest job first, the shortest job first becomes the first come first serve, and the longest job which has the highest response ratio next. So, definition of non-primitive scheduling. Non-primitive scheduling is a type of CPU scheduling where it starts the execution on the CPU. It runs to completion without being interrupted by other processes. This means that the CPU is allocated to a process and that process retains control of the CPU until it either completes its execution or voluntarily yields the CPU. Explanation: in non-primitive scheduling, the operating system does not forcibly removes a process from the CPU. Even if a higher priority process becomes ready for the execution, the currently running process will be continued until it either completes its execution, moves to a waiting stage. Once the process has finished its execution or it's waiting for an input-output operation, the CPU can be allocated to other process in the ready queue. So this is the diagram of the non-primitive scheduling. So the new process, this is a ready queue, and this is a trail, and this is a head, and this is called the waiting period, which requires the input-output block the resources from there's which is processed to the running and then comes to the exit. Definition of primitive scheduling. Primitive scheduling is a type of CPU scheduling where the operating systems can be interrupted and a currently running process to allow other process. Typically, the higher priority to the use of CPU. This type of scheduling allows the CPU to be reallocated based on the certain criteria such as process priority, ensuring that the most urgent tasks are handled promptly. Explanation of this primitive scheduling. In primitive scheduling, the operating system can forcefully take the CPU away from the running process in favor of another process. This is typically done when a higher priority process enters the ready queue. A process in the ready queue has waited longer than a predefined time slice. A process in the ready queue meets certain criteria that makes it more appropriate to run immediately. So this is a diagram of the primitive scheduling, which has a new process and which has a trail and head. The queue starts from the trail to the head and then just passes to the running and just exit. If there any kind of things which is in between, it requires the input output resources block resources, and then which goes through the waiting block and then goes back to the trail and head, which is called the ready queue. Similarities and differences between non-primitive and primitive scheduling. Process interruption. Primitive scheduling allows process interruption. In primitive scheduling, a currently running process can be interrupted to allow other process, typically one with a higher priority, to take over the CPU. This ensures that the urgent tasks are handled promptly, even if it means temporarily pausing the execution of the current process. Whereas for the non-preemptive scheduling, in non-preemptive scheduling, once a process starts executing on the CPU, it cannot be interrupted. The process will run to completion or until it volunteers gives up the CPU. Example for input-output operations. This approach prevents the CPU from being reassigned to other processes, even if a higher priority process becomes ready. Implication on process turnaround time and response time. Turnaround time, primitive scheduling, the ability to interrupt process can lead to faster turnaround time for higher priority or time sensitive process. However, lower priority process might experience increased turnaround time due to being primitive frequently. Whereas for the non-primitive scheduling, each process runs to completion in order to their schedule. This can result in longer turnaround times for process that are queued behind longer running tasks. Response time for the primitive scheduling can receive faster response since they can interrupt currently running tasks. Whereas for the non-primitive scheduling, the process can have to wait for longer running task for complete. This can be determined in the environments where quick response are essential. So this is the difference between the primitive scheduling and the non-primitive scheduling. So in the primitive scheduling, we can see the interrupts are present in between. There are two processes which are switched to from one state to another and one back to other. Whereas for the non-primitive is also same for switch to one and one to one. So whereas for the primitive, we have the interrupts in between the two different blocks when we switch from one state to another. So this is a basic difference between the two primitive scheduling and the non-primitive schedulings. So the priority scheduling. Priority scheduling is a CPU management technique where processor are assigned a priority level. The CPU is allocated to the process within the highest priority. When process have equal priority, they are generally scheduled in the order they arrive, following a first come served principle within the priority category. Process scheduling based on the priority level. Priority assignment. Each process receives a priority value which can be determined by a factor such as the process significance, the resources it requires, or user defined settings. Scheduling. The scheduler selects the process with the highest priority from the ready queue. If multiple processes have identical priority, they are scheduled based on their arrival order. Execution. The CPU executes the process that has been selected by the scheduler. So this is the diagram of the thing for the priority scheduling. This is the classifier where the arrivals are come, which is based on the higher priority queue, and this is the lower priority queue, and this is the link which joins the higher priority queue and the lower priority queue based on the priority given by the classifier, and this is the output. Primitive and non-primitive versions of priority scheduling. In primitive priority scheduling, if a new process arrives with a higher priority than the currently running process, the operating system interrupts the running process and allocates the CPU to the new higher priority process. Behavior. The primitive process is moved back to the ready queue and will only resume when there are no other high priority process in that queue or when it is regains the highest priority. For the non-preventive priority scheduling and non-preventive priority scheduling, the currently running process is allowed to complete its execution even if a new process with a higher priority arrives in the ready queue. The CPU is only allocated to the new process after the current one finishes. Behavior. Once a process starts running, it will not be interrupted by the processes. Regardless of the priority, the higher priority process will have to wait until the CPU becomes available. The key difference for the primitive and non-primitive allows interruption of running process by high priority ones, leading to the faster response time for critical tasks, but potentially increases the turnaround time for the lower priority processes. For the non-primitive, ensures that once a process starts, it runs to completion, which can delay higher priority processes, but provides predictability in process execution. Priority-based non-primitive scheduling overview. Um, Priority-based non-priority scheduling is a CPU scheduling strategy where processes are assigned priority level and the CPU allocates resources based on their priorities. In this approach, once a processor with a higher priority starts executing, it runs to the completion without being interrupted by the other processes. Priority assignment and priority selection, uninterrupted execution, fairness and starvation, and some of the cases which they are used. Okay. For the priority assignment process in the ready queue are given a priority level based on factors like importance, resource needs, or custom criteria. For the process selection, the CPU scheduler picks up the highest priority process for the execution, which ties broken by the arrival time, first come, first served. For the uninterrupted execution, once a process begins, it runs to the completion without being regardless of the priority of the incoming process. Fairness and starvation, this method prioritizes urgent tasks but may cause lower priority process due to its identity of higher priority task keeping arriving. Users case ideal for system where a task order is critical or interruptions could have a negative effect such as it's in real time or batch processing environment. How it works: priority determination, high priority selection, handling equal priorities, uninterrupted execution, and subsequent process selections. Each process in the ready queue is assigned with a priority based on the factors such like importance, resource needs, or user defined settings. For the highest priority selection, the CPU scheduler identifies the process within the highest priority among those in the ready queue. Handling equal priorities: if multiple processes have the same priority, they are scheduled based on their order of arrival. Uninterrupted execution: once the process with the highest priority starts running, it continues execution until if it's fully completed without being interrupted by other processes. Subsequent process selection: after the current process are finished, the scheduler then selects the next priority process from the queue, and then the scheduling cycle is continuous. So thank you so much. So in this video we discussed about the priority based and non-priority based schedulings and the key difference between them, as well as the primitive and non-primitive versions of priority schedulings. And we have discussed about diagram which gives a detailed explanation of the priority scheduling, as well as we have discussed about the difference between the non-priority scheduling and primitive schedulings, implication on the process turnaround time and response time as well, and the similarities between the primitive and non-primitive schedulings and the difference between them as well. And we have discussed what is primitive scheduling and non-primitive scheduling, as well as we have also discussed about the diagram explanation of the primitive and non-primitive, and the scheduling of the CPU scheduling and how it's divided into different types like primitive and non-primitive. So thank you so much.